Hi students. Today I say something about the interference of light. There are books, you will go through the books, but before you go through the books, I should say something about the interference which will help you to understand the actual things written in the books. Because basically you must have to know the what does interference means. Interference means, so interfere, it's a simple word, interfere. So there is one interference between, so one dependence of one thing with the others. There is one interference. Interference means there are two things, suppose. And interference between two things means it has a dependence on these, it has a dependence on these. If it has to do something, then you have to take it these things again like this. So interference of the waves here, you have in the chapter the physical optics, and there you see that interference of the waves. There are two waves. Now when you enter into the chapter in your books, you will see that first of all there is one condition that has been written here, the conditions for the sustained interference. Now this very basic point, sustained, what does it mean? Sustained interference pattern. Sustained means অনেকক্ষণ ধরে থাকবে, অনেকক্ষণ ধরে থাকবে এরকম interference pattern. It will stay for longer. It will be there. Until and unless you have sustained interference pattern, you cannot see it. You cannot observe, because our persistence of efficiency is 1/1/20 অর্থাৎ 20 second 1/20 সেকেন্ডের মাঝখানে, if you have this place here, if you have one thing here, suppose this is my cover of the sunglass, cover this glass, it is here. Now if you sit this here in this position, but your eye will observe it up to 1/20 second here, অর্থাৎ 1/20 সেকেন্ড পর্যন্ত এখানেই দেখবে, 1/20 সেকেন্ড পর্যন্ত এখানেই দেখবে চশমাটা এখানে রয়েছে, তারপরে সেখানে গেছে, অর্থাৎ up to the limit of 1/20 second it will be there, but you have shifted, already you have shifted. So this is called persistence of vision. Now suppose the two waves are there, suppose there are two waves are going, two waves are passing through. Now both these two waves are interfering, suppose both these two waves are interfering. Now after this interference, what will happen? There will some bright fringes, some dark fringes, bright fringe patterns, dark fringe patterns will be there. But bright fringe pattern and the dark fringe patterns, so that will change within a short span of time. If the interference are not sustained, this interference অনেকক্ষণ ধরে না থাকে, কি হবে? Bright pattern এলো, and within a very short span of time it will again come to a dark. That particular point will become dark, and then that particular point will become again bright, and this and this and this. So what the basic point is that if this is like that, then we cannot observe. First of all, before we say that we cannot observe, first of all we should know what will be the time gap. What is the actual time gap between this if the interference is not sustained? Now, to understand this, I have to go again another basics. How is the light produced? কিভাবে light তৈরি হচ্ছে? So you see according to Bohr's theory, if you want to explain. So there are proton in the innermost part, and the electron that is being revolving around that. So the electron when the electron from the lower energy level will pass on to the higher energy level. After getting certain energy from electrical energy, maybe from other energy, other kind of energy, thermal energy or any other kind of energy, and getting energy, the electrons is jumping from the lower level to the higher level orbit. Now when this electron comes from the higher to lower orbit, the energy E2 minus E1 according to Bohr's theory is equal to h nu. H is the constant, and nu is the frequency of the light, and that will come, frequency of the wave rather, Now if this is under the visible region, this nu, then we can see this light. So this is the actual basis of the production of the light from the point of view of the atomic theory. From the point of view, of course, from the considerations of Bohr's theory. Now, this is E2 minus E1 is equal to h nu, that energy will come. Now the question is that if there are two different sources, suppose two candles, there are two waves coming from these two candles, and that will also interfere, but interference will be there, but we cannot see this interference. We cannot see the interference between the two candles because there is a very speedy phase differences occurring there, or very speedy interference patterns, one bright, dark, bright, dark, bright, dark, you will see. And you cannot observe. If you see bright, you will see bright again, because again that will come within the limit of 1/28 seconds that I have told you, persistence of vision. Because, now see, so this is one cover. Now, it will be cherry. It will come down. Then what is the time gap? Amar cherry dawa and come. So there is a very minute time gap between these. Actually, this is the time gap is basically 10 to the power minus 8 to 10 to the power minus 11 seconds. When an electron jumps from the lower orbit to higher orbit, it will not stay there. It will come down to the ground state. It will come down to the lower orbit after a gap of 10 to the power minus 8 to 10 to the power minus 11 seconds. It means in 1 second, 10 to the power 8 times the wave will go. The wave will pass through, the wave will emanate, the wave will emerge. So after, in 1 second, 10 to the power 8 times. So what is the time gap between these two interference? 1 by 10 to the power 8 second, 10 to the power minus 8 second. And our persistence of vision is 1 by 20 seconds. So how can you see? You will see only the bright fringes, you will see only the dark fringes. If you see bright, then it will be always bright, you will see dark. So you cannot see the interference pattern. So to see, to observe, to view this interference pattern, what you need to have? You need to have the interference pattern must be sustained. And to make it sustained, the phase difference between the two waves must be constant. And this is the first condition, that the phase difference must be constant to have a sustained interference, to view this interference pattern, to observe this interference. So the conditions for the sustained interference pattern, what the actual need is, the phase difference must remain constant. Now, to have a good contrast, to view it very in a very good manner, what you have to have? You have to have the amplitude between the two waves, that is the two interfering waves. Two or more waves may be there, but I am talking about two waves. The amplitude between these two waves, the difference in the amplitude of these two waves must not be very far, because we know the intensity I max by I minimum is equal to I max minus I minimum divided by I max. But you will read it in the books. The basic fundamentals is that amplitude, the difference in amplitude must be there. To have this contrast, without having any contrast, you cannot see the interference pattern in a very good manner. So my point, what I would like to say, the point that has been written in all books, that word, sustained, what does it actually mean? So before you go to the interference, before you go to a big calculation, you must have to have an idea about the interference patterns and about the sustainable things, how it can be sustained, and for this, what must be the conditions. Thank you all. Here, this is the end of my lecture. I think all enjoyed it. And you make it just digest it, just have it, and go to the books. You can enjoy the books also. Thank you.